Hello everyone, my name is Qiao Xue. This is my presentation for EEL6825 pattern recognition in University of Florida. This presentation is divided in 7 parts. The topic I choose is face recognition. Face recognition is a method to recognize a certain human face from the database. It can be used in many places, like for the purpose of human identification or find the certain people in video or CCTV. There are some approaches to do a face recognition. First one is use PCA and classified by Euclidean distance. Another way is classified by SVM, and the third way is classified by neural network. Let me introduce the principal component analysis, which also called PCA. PCA is to extract the major information from a set of images. First, it converts the image into a one-dimensional vector. After that, we compute the average face from the input image, and we compute the covariance matrix A according to the average face. Once the covariance matrix A is computed, we compute the eigenvalues and eigenvectors from the matrix. Then we sort the eigenvalues from the high to low, and we pick the largest k lambda, and the corresponding eigenvectors is called eigenfaces, which preserve the major information of the input images. Then we project the image into the eigenface space. It converts the image into a linear representation of the eigenfaces, and it becomes a k-dimension vector. This is to show how the PCA works. These 5 pictures are the input images, and then we compute the average face from the input image, and then we compute the eigenvalues and sort it, and we pick the eigenfaces. After that, we project the input image into the eigenface space. We can see that the projected image preserves the major information from the input image, but it also loses some detailed information. But it's not mentioned to the classification. But here is some problem when we use Euclidean distance to classify. We can see that after the image were projected into the eigenface space, the image in one class will close to each other in the space, while other points are far from this class. But if we have a new person image, it will far from any class, but it might be classified into one of these class, which brings some problem. So we use a new feed-forward neural network to do a classification. After input an image into the neural network, it will have an output which range from 0 to 1 for a class. If the output is less than a threshold, it will be seen as it doesn't belong to any class existed, so it will be defined as a new person image. So let me simply introduce the neural network. Here is a very simple example of neural network, which has an input layer, a hidden layer, and an output layer. The hidden layer is computed from the input layer by a weight matrix, and the output layer is computed by hidden layer product by a weight. So how do we train the network? The output will compare to an expected output, and it has an error. Then we conduct the error back propagate to the input to justify the weight matrix. So after many iterations, the weight matrix will be justified to let the output is very close to the expected output. This is how the training works. So let us compute the two methods of their performance. The first method is use neural network, and the second one is use Euclidean distance. We compare their recognition percent, how much they can correctly recognize input image. We can see that when the training set is become larger, it has a better performance, and that is reasonable because when we have more training data, the network is more likely to be success. And these two methods have a similar performance in the recognition rate, but to the recognition time, the first method when the testing set is become smaller, the recognition time is also become lower and lower. But for the Euclidean distance method, when the training set and the test set have a similar size, the recognition time get to a maximum. That is because the total training set, the total image is fixed. So when the training set is similar to the test set, they have the most number to compute the Euclidean distance between them. Therefore, use a neural network has a better recognition time than the Euclidean distance method, and it also can recognize a new person image from the existing class. Therefore, use a neural network is more beneficial for real tests. Okay, let me explain my project. First, we create a database from the ORL image database, and then after that we perform a PCA function. The PCA function can calculate it produce eigenfaces according to the mean of the input images and according to the covariance matrix. After we produce eigenfaces space, we project the input image into the eigenface space. Then we have a k/1 projected image. Then we use these k/1 samples to train our neural network. Use the training data. and we use the test data to run a simulation to see how the recognition rate is. This is begin to training the neural network, and because the training it have to take a long time. And in the end, the trained network will input is come into the trained network, it will have an output which is range from 0 to 1 for each class. And we find the max output and also have to larger than a threshold, that means this belongs to this class. But if the output is no bigger than a threshold, it means this input doesn't belong to any class. That's all. Thank you for watching.